All right, let's dive into something pretty fascinating today. We're talking about AI agents. You know, those AI systems that can actually do things out there. They can plan, use tools, maybe even team up.
Right, and we've been looking through these sources articles, some research notes focusing on um, protocols, really, and some breakthroughs with these agents.
Yeah, and what kind of jumps out right away is this problem, fragmentation.
Mm.
You've got these powerful agents, but it feels like computers before the internet had rules, you know, before TCP/IP,
Exactly. They can't really talk to each other easily. It's a bottleneck.
a big one. So that's our mission for this deep dive.
Yep.
Figure out what this fragmentation actually means, how people are trying to fix it with these new protocols,
Yeah.
and why this is just so crucial for where AI is going. We're even going to look at a really cool specific example later.
Sounds good. It's definitely a key area right now.
So diving in, the sources are clear. Right now, most AI agents are kind of isolated, siloed.
That's the word they use. Yeah, siloed.
They have their own ways to connect to tools, specific APIs, custom wrappers. It's all a bit bespoke.
Yeah, think of it like everyone's speaking a totally different language. You've got these really smart systems, right?
Yeah.
But they're locked in their own worlds. You can't easily scale up complex tasks that need different types of agents working together.
Just because they don't have a shared way to communicate or understand each other.
Exactly. It's just inefficient. This fractured ecosystem, it's a real drag on progress, a big bottleneck.
Okay, so if they're all speaking different languages, how do you fix that? What are the sources suggesting?
Well, the strong consensus looking through this material is standard protocols. That's the key.
protocols, okay.
It's really seen as, the missing infrastructure layer. Just like the internet needed TCP/IP, HTTP, all that.
Right, to let everything connect.
Yeah. Agents need that too. A common language, common rules. How to find each other, talk securely, know what the other agent can actually do across different companies, different platforms.
So it's like building the roads and maybe the traffic rules for this AI world.
That's a great way to put it. Exactly. These protocols, they're the missing link between having powerful individual agents and enabling, true large-scale collaboration, working together effectively.
And without that, multi-agent systems just don't really take off.
Pretty much. Their potential is really capped. The sources mention one specific protocol that seems quite developed already, Anthropic's Model Context Protocol, MCP.
MCP. Okay, what's that one focused on?
MCP is mostly about agents talking securely to tools or external resources.
Ah, okay. Tools, not other agents.
Right. It handles things like, is the agent using the tool correctly? What about data privacy when it hits an external system, managing, the technical side of calling different APIs properly?
So it's like the rule book for an agent using a hammer or a database or something.
Kinda, yeah. A secure handshake, making sure that interaction works reliably and safely.
Okay, that makes sense. Agents need to use tools. But what about agents talking to other agents? That feels even more like the core collaboration piece, right? If one agent needs help from another.
Absolutely. You nailed it. That's the whole next level. Agent-to-agent communication. A2A. And the sources discuss several protocols being worked on specifically for that A2A interaction.
Okay, so MCP for tools, A2A for agent-to-agent chats. Got it.
Right. And even within A2A, there are different flavors.
Yeah.
The material mentions one protocol actually called A2A, which came out of Google. This one seems more geared towards internal use.
Yeah.
Like within one company.
How does that work?
It uses something called agent cards.
Agent cards, like baseball cards.
Kind of, yeah. More like a digital profile, usually JSON. An agent publishes its card saying, here's what I do, here's the data I need, talk to me like this.
Okay.
Then other agents within the company can look it up, find the right agent for a task, see its card, and know how to delegate stuff to it. Good for managing your own internal zoo of agents.
Right. Makes sense for a big organization. Keep things tidy internally.
Exactly. But then there's another one mentioned, the Agent Network Protocol, AMP.
AMP, different.
Yeah. This one's open source, and it's aiming bigger. It's designed for agents talking across different organizations, different companies, labs, whatever.
Ah, so more like the public internet, less like a company intranet.
That's a really good analogy, actually. A2A, Google's one, is like the corporate intranet for agents. ANP is trying to be the public internet for agents.
Yeah.
Decentralized collaboration. Agents that maybe don't know each other beforehand.
Okay, that's a key difference. Internal versus external.
Precisely. And the sources toss out a few other names, too, just showing how active this space is. There's Agora, which sounds interesting. It's more user-centric. Agents kind of figure out how to talk using these protocol documents, maybe even in natural language. less rigid.
Mm.
And then you've got really specific ones, domain-specific, like CrowdES or SPPs. Those are for agents controlling robots, like in a warehouse or something. Or PXP and LKA, which are focused on agents helping humans directly. So they need good human-agent interaction rules.
Oh, okay. So it's not just one answer. It's a whole ecosystem of communication needs.
Exactly. Different protocols for different kinds of agent teamwork.
Man, that's a lot of acronyms. MCP, A2A, ANP, Agora. How do people even, compare these? How do you know which one is good or right for a job?
Yeah, that's a really important question. And the sources actually get into this. One paper lays out specific criteria for evaluating these protocols.
Okay, like what?
Well, the big ones they mention are security, obviously. Is the communication safe, private, especially with sensitive data flying around?
Crucial, yeah.
Then operability. Basically, how easy is it for developers to actually use this protocol? Is it clear, well-documented? You don't want it to be a huge pain to implement.
No, it needs to be practical.
Extensibility. AI changes fast.
Yeah.
So can the protocol adapt? Can you add new features, support new kinds of agents or tools later on without breaking everything?
Future-proofing, kind of.
Exactly. Trustworthiness. Is it reliable? Does it work consistently? Can you trust that agent interactions will happen as expected?
Makes sense.
And finally, integration capacity. How well does it connect different things? Agents on different platforms, maybe cloud versus local device. Can it bridge those gaps?
Okay, so it's way more than just can they send messages. It's about making the whole interaction solid, secure, usable, adaptable.
Exactly. It's about building a robust communication system. These criteria are how the community is sort of weighing these different approaches, figuring out what works best where. It's complex, but super important work.
Okay, this is definitely getting technical. And you might be listening and thinking, all right, protocols, standards, why should I care? How does this affect me?
It's a fair point. It sounds like plumbing, maybe. But the sources really emphasize that these AI agents are getting really capable. They're moving out of the lab. They could become like basic infrastructure in business, science, maybe even our homes eventually, everywhere.
Yeah, it doesn't feel like sci-fi anymore. It feels
closer.
Right. And if they stay fragmented, stuck in those silos we talked about, their potential is just limited, massively limited. Imagine trying to run, I don't know, global shipping if every port used a completely different, incompatible system for manifests. It would be chaos.
Yeah.
Utterly inefficient.
Yeah, nothing would work together.
So solving this fragmentation with protocols, it's not just about neat code. It's fundamental to unlocking what these agents can do. It lets them team up on big problems, share info securely, automate whole workflows across different systems. That's where the real value is going to come from.
So they become more than just clever tools. They become part of a bigger, coordinated system. Exactly. Whether that's making businesses run smoother, speeding up research by connecting different AI analysis tools, or even just making our personal tech work together better for us. Without protocols, they're like brilliant specialists who just can't coordinate on a complex surgery. With protocols, they can potentially form that expert surgical team.
Okay, that makes the stakes clearer. It's about enabling that next level of capability.
Definitely. And speaking of capability, let's switch gears to that concrete example you mentioned. The sources highlight this really interesting breakthrough with an autonomous AI agent in medicine.
Yeah, this sounded pretty wild. What did it do?
So this was research from TU Dresden and collaborators. They built an agent designed to help doctors with clinical decisions in oncology, cancer care.
Okay, high stakes.
Very. And in their early tests, using simulated but realistic patient cases, this agent hit 91% accuracy.
Whoa, hold on. 91% accuracy on recommending cancer treatments or diagnoses on simulated cases.
Yeah, based on the simulated patient data provided. It's striking.
Wow, that seems incredibly high.
It is. And crucially, the sources point out, it wasn't just accurate, it was also grounded. It correctly cited official treatment guidelines 75% of the time.
Ah, so it showed its work, basically, based on actual medical standards.
Exactly.
Yeah.
Which is vital in medicine. You can't just have a black box making recommendations.
So how did they build this thing? Is it just a standard LLM?
It's built on GPT-4, but it's way more than that. They gave it specialized tools. It can analyze medical images, MRI scans, CT scans. It can help graph radiology reports. It can even predict genetic mutations from molecular data.
Okay, so it has specialist skills.
Right. And it uses search tools, PubMed for research papers, OncoKB for cancer knowledge, Google for general info to pull in the latest evidence. It keeps itself up to date.
So GPT-4 plus a whole medical toolkit and library access.
That's a good summary. And critically, the training wasn't just random web data. They fed it over 6,800 official oncology documents. protocols, trial data, guidelines.
So it learned from the best available medical knowledge?
Precisely. That grounding in high-quality data is likely key to its performance.
And the testing, that 91%, was it on easy stuff?
Nope, they stress it was on 20 complex, realistic cancer scenarios designed to be challenging. And human experts checked the agent's outputs for accuracy and made sure the citations were relevant.
Okay, 20 cases isn't thousands, but still, that's genuinely impressive potential. What are the implications?
Well, the researchers are cautious. It's early stage, obviously. Needs way more testing, validation, but the potential implications are huge. If this holds up, and with the right safeguards and absolutely critical human oversight, this is decision support, not replacement.
Right, assisting the doctor, not being the doctor.
Exactly. This kind of agent could become a standard tool,
Yeah.
helping oncologists manage the information overload, consider all the latest evidence, maybe improve consistency in care. And you can imagine this extending to other complex medical fields too.
Okay, see, that example really brings the power home. An agent capable of that kind of analysis. Now imagine that agent being able to seamlessly talk to another agent that manages patient scheduling, or one that finds clinical trials, or one handling insurance paperwork, all using a shared protocol, like ANP or something similar, reliably, securely. That's the future these protocols unlock, right?
That's exactly it. You have these agents getting incredibly good at specific, complex tasks, like that medical analysis. But for AI to truly scale, to weave itself into how things actually get done, we absolutely have to solve that fundamental communication problem. How do they find each other? How do they talk securely? How do they collaborate reliably? Protocols are that missing foundation needed to build that interconnected AI future.
Right. So wrapping this up then, we've seen the problem. AI agents kind of stuck in their own worlds, fragmented. We've seen the potential solutions taking shape. These different protocols, MCP for tools, A2A, and AMP for agent-to-agent comms, each with its own focus.
Yeah, the infrastructure being built.
And we got a glimpse of the incredible potential with that medical agent example, showing what they can do individually and hinting at what they could do together.
Right. And maybe the final thought for you listening is this. Considering how fast these agents are evolving and how much we need them to coordinate for complex tasks, ask yourself, as AI agents get woven more into our world, how will their ability, or maybe their inability to communicate, effectively reshape, well, everything? The industries, the systems, maybe even our daily lives. It's definitely something worth thinking about.